Hey everyone, and welcome to this explainer. You know as well as I do, in the electrical industry, the margin for error? Yeah, it's pretty much zero. Today, we're unpacking a truly life-saving topic together: polarity and neutral integrity testing for services and submains. We're going to look closely at the mandated safety procedures that ensure these installations are actually safe to energize. Because at the end of the day, this isn't just about ticking compliance boxes. It's about making absolutely sure that everyone goes home safely. Okay, let's dive right into this. Have you ever paused to think about the absolute worst-case scenario when a system is energized with reverse polarity? I mean, the stakes literally could not be higher. One simple transposition of conductors means the entire earthing system of an installation could become a live deadly hazard. We're talking fatal consequences for anyone who touches those earthed conductive parts. So, to get a really solid grasp on how to prevent this, here's our roadmap. We'll start with the specific risks of incorrect testing, review the mechanics of the MEN system, and navigate alternate power supplies. Then we'll check our essential test equipment, and finally break down the procedures for both consumer mains and outbuilding submains. Let's get to it. All right, Section 1, the risks of incorrect testing. It's a harsh reality that failing to properly test is a major contributing factor in electrical incidents involving incorrect neutral connections. Assuming things are safe without actually verifying, that is a gamble we just can't take. So we're looking at two distinct yet equally dangerous faults here. First, a reverse polarity service. This is where the active supply is connected directly to the neutral link. It completely bypasses the service fuse and instantly energizes the whole earthing system to about 230 volts AC. Boom! Immediate lethal shock hazard. Alternatively, we have a high impedance or open circuit neutral. In this scenario, the current tries to return to the distribution system via the earth electrode. So as the installation draws more current, the potential of the earthing system rises proportionally. While one is an immediate shock hazard and the other scales up with the load, both can bypass your standard RCD protections and energize exposed metal parts. Moving on to Section 2, understanding the MEN system. To properly and safely dismantle a system for testing, we first have to understand exactly how it was built to protect us in the first place, right? The MEN, or multiple earth neutral system, relies on an interconnection between the supply neutral and the mass of earth at multiple points. If a fault happens, this link ensures that enough fault current flows to earth to rapidly trip your protective devices. But here is an absolutely critical takeaway. We can never, ever rely on the resistance of the earth electrode alone. The data is clear. Earth return impedance is almost never low enough to ensure safety on its own. If we trace the flow of electric current under normal, healthy conditions, the active conductor brings the current in, it does its work in the appliances, and then returns safely via the neutral conductor. Now, think about that MEN link connecting the neutral to the earth electrode. That is your ultimate safety valve. It keeps the voltage on earthed conductive parts, say a water pipe someone might lean against, at absolute zero. Section 3, navigating alternate power supplies. Let's face it, we aren't just working on simple grid-connected homes anymore. Between solar PV systems, battery storage, standby generators, and UPS systems, it is a crowded house compared to just a few decades ago. And these aren't just accessories, they're active power sources. The crucial point you need to remember is this: the neutral earth connection for these alternate supplies relies on the installation's main MEN connection. If you yank that MEN link without isolating these supplies at their source, you run a huge risk of energizing the neutral and earth circuits. Always isolate those alternate supplies at the source first. No exceptions. Section 4, essential safe test equipment. Before you even think about touching a switchboard, we need a strict, uncompromising check of the toolbox. Because we're testing on low-impedance sources, a Category 4 voltmeter and proper test probes are an absolute must. You're also going to need a voltage indicator, a fault loop impedance tester, a phase rotation tester for your three-phase systems, and crucially, a solid way to make an independent earth connection. And please, remember the golden rule of test gear: always verify the correct operation of your devices both before and after use. Don't let a busted meter be the reason things go south. Okay, Section 5, testing consumer mains procedures. This is where the theory actually hits the switchboard. During Phase 1, the isolation and setup, we first turn off all main switches. And yes, that includes those alternate supplies we just talked about. Next, turn off all circuit protective devices. Only then do disconnect the main earth, or MEN, followed by the main neutral. Did you catch that order? The absolute golden rule here, say it with me, is that the neutral conductor is always the last to be disconnected and the first to be connected. Finally, drive your independent earth stake into the ground at least 2 meters away from any other conductive surfaces. Now let's see how this builds into the active testing phase. Once the consumer mains are carefully energized, you verify the voltages against your independent earth. The main neutral to the line terminal should read your phase voltage, 230 volts. The main neutral to your independent earth, that must be 0 volts, proving the neutral is not energized. The earth to independent earth must also be 0 volts, but the line terminal to independent earth must read 230 volts. Finally, you run a fault loop impedance test on the active and neutral, which needs to give you a result of less than 1 ohm. Hitting these exact numbers is how you prove polarity and neutral integrity without a shadow of a doubt. Section 6. Submains and Outbuilding Tests. When you're dealing with a separate outbuilding that incorporates its very own MEN connection, the testing approach requires some vital adaptations. The big, critical difference here is dual isolation. We have to start upstream at the main switchboard and turn off the submain protection device. Then, we literally walk down to the outbuilding and turn off the main switches and protective devices locally. Only after ensuring total physical isolation across both boards do you disconnect the outbuilding MEN, then the submain neutral, and set up your independent earth. After proving polarity with those exact same voltage checks we discussed earlier, we hit the reconnection phase, and you must maintain a fail-safe mindset here. Leave the upstream protection off. Then, reconnect the submain neutral first, followed by the MEN. Only after that do you restore power. To wrap it all up, perform a fault loop impedance test at a convenient socket outlet to verify that MEN integrity, and use a proximity tester to confirm that absolutely no part of the earthing system is energized. What we should really take away from all this boils down to one simple, undeniable truth. In our trade, assumptions are deadly. Visual inspections are great, sure, but they can't reveal a transposed overhead line down the street or a high-impedance neutral. Rigorous, uncompromising procedural testing is literally the only way to guarantee that the installation you're walking away from is electrically safe. I want to end on this direct quote taken straight from the Safe Systems of Work. Take caution and assume all exposed parts are energized, until isolated and proved de-energized. It really makes you wonder, doesn't it? How many close calls or near misses happen every single day simply because someone trusted their eyes instead of their meter? Think about that next time you're at the board. Thank you so much for joining me for this explainer. Stay safe out there and never stop verifying.